Right now, as you sit in your chair, you're moving at 1.4 million miles per hour. You feel absolutely nothing. Your coffee does not ripple in its cup. The room around you is silent and still, but the floor beneath your feet is currently hurtling through the vacuum toward a gravitational anomaly known as the Great Attractor. In the time it took you to read those first few sentences, you have already travelled roughly 2,000 miles through the dark. We are moving at a speed that defies human comprehension toward a destination we cannot even see. It lies hidden within the zone of avoidance, a region of space permanently obscured by the thick, dusty disk of our own Milky Way. We are essentially flying into the deep universe blind, reeled in by an invisible titan. If this is the kind of investigation that interests you, subscribe now. The investigation begins here. To understand the journey we are about to take, we must first confront the sheer, terrifying scale of the architecture we live in. There are at least 70 sextillion stars in the observable universe. That is an absurd number. To make it real, imagine every star in the cosmos is shrunk down to the size of a single grain of sand. If you were to stand in a desert made of these stars, the typical separation between each individual grain would be roughly 6 miles. That is the density of our universe. A grain of sand in the middle of a city, and another in the next town over, with nothing but an absolute frozen abyss between them. For decades, we have stared into this abyss through the eyes of the Hubble and James Webb telescopes, mapping billions of galaxies and staring back toward the very beginning of time. But looking is not the same as going. To truly reach the edge, we have to leave the shallows of our solar system and enter interstellar space, a place that is not merely empty, but actively hostile to the laws of biology. We are going to imagine we have constructed a ship capable of a constant 1g acceleration. This is a specific choice. By accelerating at 10 meters per second every second, the ship creates a force that pushes the crew toward the floor with the exact same strength that the Earth pins you to the ground right now. Life on board would feel perfectly normal. You could walk, eat, and sleep just as you do in your own home. But this comfort is a deal with the devil. A ship that undergoes constant acceleration starts slow, but its gains accumulate like compound interest. After just 3 weeks, you would overtake Voyager 2 and leave the solar system behind forever. By the end of the first year, you would be travelling at nearly the cosmic speed limit. It is here, as we approach the speed of light, that the physics of the journey turn from a scientific wonder into a visceral horror. Most documentaries treat the vacuum of space as a hollow stage. They tell you that you need perfect shielding, and then move on. But the reality is far more violent. Space is permeated by a thin stream of interstellar gas, roughly 1 hydrogen atom per cubic centimetre. At the speeds we are reaching, those lonely atoms are no longer gas. They become nuclear sandpaper. When your ship strikes a single atom at near-light speed, it is not a collision. It is a high-energy particle strike equivalent to a tiny nuclear detonation against the hull. You aren't just travelling through the vacuum, you're being relentlessly sandblasted by it. To move through the empty universe is to subject your vessel to a continuous microscopic bombardment that threatens to erode your only protection into nothingness. And then there is the psychological price of the velocity itself. By the time you've been travelling for just 15 months, your Lorentz factor hits 2. This is a mathematical term that describes a terrifying human reality. Time has split. For you, on the ship, everything is normal. But if you could look back at the Earth through a telescope, you would see the planet moving in fast forward. The people you love are flickering through their lives like old film reels. Your children are aging years while you age months. Every radio letter you receive from home is a ghost story, detailing political scandals, scientific breakthroughs, and family deaths that happened months or years before the paper even reached your hand. As we accelerate further, you begin to disconnect from the rest of the universe in a very real way. Looking ahead, the constellations you have known since childhood begin to warp. They distort into a tunnel vision illusion, bleeding into high-energy ultraviolet light that your eyes cannot even process. Behind you, the sun fades into a dim, red ghost, eventually becoming so red-shifted that it disappears into the infrared spectrum, leaving you in total darkness. You're becoming a historical relic. If you were to turn the ship around now and head back, you would return to an Earth that has moved on without you, a world where you are a monument to a time that no longer exists. You're no longer an explorer, you're a passenger in a time tomb hurtling into an absolute nothingness. We are currently leaving the local fluff, a region of gas 30 light-years across that houses our sun. Ahead of us lies the local void, a giant black abyss that occupies 40% of the night sky you see from your backyard. It is 150 million light-years of silence so profound that even the most advanced telescopes find almost nothing inside it. If you were to step outside the ship in the heart of this void, the darkness would be absolute. There would be no stars to guide you, no landmarks to anchor your mind. Just you, the ship, and the growing realization that the universe is not just big, it is indifferent. The journey has only just begun. We have left the shore and the ground has disappeared beneath us. We are now falling toward the edge of everything, and there is no way to stop the descent. We are now 4 billion miles from home. The sun, which once dominated your sky as a blinding, nurturing furnace, has shrunk to a brilliant tiny pinprick, a cold white diamond that provides no warmth, only a faint ghostly illumination. You're standing at the edge of the solar shallows, crossing into a region of the cosmos where the rules of the inner system no longer apply. Ahead of us lies Pluto, a world that was long dismissed as a dead, frozen rock, but as we approach, the data reveals something far more unsettling. Pluto is roughly 40 astronomical units from the Sun. To make that number real, if you were to fly a commercial jet at 500 miles per hour, it would take you nearly 1,000 years to reach this point. At this distance, Pluto is a dark and indistinguishable object, a murky brown disk that defies the gaze of even our most powerful telescopes on Earth. It follows an elongated, eccentric orbit, completing a single revolution every 248 Earth years. This means that since the day Pluto was discovered in 1930, it hasn't even completed half of its journey around the Sun. But do not let its distance fool you into thinking it is empty. Pluto is a world of monstrous geology and toxic secrets. As the ship glides over the equatorial zone, you see it, a massive pale feature shaped like a human heart. This is Tombor Regio, a vast basin 2,300 kilometers across, large enough to occupy a quarter of the entire planet's surface. The western lobe of this heart, known as Sputnik Planitia, is a smooth, featureless plain of frozen nitrogen, carbon monoxide and methane. It is blindingly bright, reflecting up to 90% of the sunlight that hits it, looking like a vast, polished mirror of ice in the middle of a dark desert. But this heart is not a symbol of life. It is the site of a cosmic trauma. Scientists believe Sputnik Planitia formed roughly 100 million years ago when Pluto was struck by a massive celestial body. The impact was so violent that it punctured the crust, creating a giant basin that was immediately filled by the contents of Pluto's interior. If you look closely at the surface of this plain, you see a strange cellular pattern. Smooth areas 20 to 30 kilometers wide, separated by shallow depressions and hills. This is not a static landscape. These are convection cells, resembling the patterns you see in a pot of thick soup heated from below. This leads us to the most unsettling discovery made by the New Horizons probe. This is not speculation. This is what the internal models confirmed. Pluto's core, a 1,700-kilometer mixture of rock and ice, may still be generating enough heat to melt its inner mantle. Deep beneath that nitrogen ice crust hides a toxic, salty ocean of liquid ammonia. Imagine an entire sea, miles deep, trapped in total darkness, composed of a freezing, poisonous chemical cocktail that would dissolve human tissue in seconds. This ocean is not just sitting there. It is a pressurized chemical engine that drives the planet's geology, pushing up through the crust in a process known as cryovolcanism. On Pluto, volcanoes do not erupt with fire. They erupt with slushy frozen mixtures of water, ice and ammonia that solidify instantly in the minus 230 degrees Celsius air. Surrounding this toxic heart are mountain ranges that challenge our understanding of physics. To the west lie the Hillary Montes, rising 3.5 kilometers into the thin atmosphere. To the south, the Tenzing Montes tower over 6 kilometers high, nearly as tall as the Himalayas. But there is a complication. These mountains are not made of rock. They are composed of pure water ice. At these temperatures, water ice becomes as hard and rigid as granite, capable of supporting jagged, massive peaks that would be impossible on a warmer world. As we move further east along the equator, the landscape turns into a nightmare of shadows. You encounter a chain of dark spots, hundreds of kilometers wide, known as maculae. These are named after dark deities from human mythology, and the largest is Cthulhu Macula, a 3,000-kilometer scar of deep reddish-brown material. The data suggests these dark regions are remarkably old, pockmarked with craters that have survived for billions of years. Their dark colouring comes from tholins, complex organic molecules formed when ultraviolet light from the distant sun breaks apart methane and nitrogen in the atmosphere, raining a dark, tar-like soot down onto the surface. It is a slow, relentless accumulation of cosmic smog that has turned half the planet into a grim, light-absorbing abyss. The atmosphere itself is a ghost. It is composed primarily of nitrogen, but it is currently performing a death dance. Despite Pluto moving further from the Sun, its atmospheric density has tripled over the last 30 years. As the Sun's rays strike the North Pole, nitrogen ice evaporates, thickening the air before the coming winter causes it to freeze and collapse entirely, snowing out onto the surface until the planet is left in a total vacuum. And then you see its companion. Charon is not a moon in the traditional sense. It is a partner in a gravitational locked step. Charon is so large, nearly 11% of Pluto's mass, that the two bodies actually orbit a common centre of gravity located in the empty space between them. They are tidally locked, forever facing each other with the same side, like two dancers frozen in a permanent silent embrace. Charon's surface is even more alien than Pluto's. It is dominated by Vulcan Planum, a vast plain the size of a European country, and Kubrick Mons, a 40-kilometre-wide mountain surrounded by a moat 2 kilometres deep. At its north pole lies a giant blood-red stain called Mordor Macula. This is a trap for gases escaping from Pluto's atmosphere, which drift across the void, settle on Charon's pole, and are baked into red tholins by radiation. Our time in this system is short. The New Horizons probe, which gave us these images, is already 50 astronomical units away, hurtling into the chilling recesses of space where its systems will eventually fail by 2030. We are approaching a critical deadline. In the year 2011-13, Pluto will reach its aphelion, the furthest point in its orbit, 49.3 astronomical units from the Sun. At that moment, it will become a dark, indistinguishable object in an eternal abyss, the last shore before the great cosmic drop-off. Beyond this point, there are no more planets. There are no more friendly landmarks. There is only the Kuiper Belt, a vast circumstellar disk of icy remnants and dwarf planets like Eris and Sedna, stretching out into the dark. It is a field of cosmic icebergs, the rubble left over from the birth of the solar system 4.5 billion years ago. As we cross this boundary, you feel a deep, existential shift. The Earth is now so far away that it is not even a speck of light. It is a memory. You are entering interstellar space, a vacuum so rarefied that there is on average only a single hydrogen atom per cubic centimetre. You are leaving the safety of the campfire. You're turning your back on the last bit of home you will ever know. Ahead of us lies the Oort cloud, a theoretical shell of 1 trillion icy bodies that marks the true limit of the Sun's gravitational reach. It will take us a year at the speed of light just to reach its inner edge. We are now passengers in a tomb hurtling into nothingness, crossing the threshold into a universe that is vast, silent, and entirely indifferent to our arrival. To reach the edge of the universe, we have to make a choice that defies our biology. We have to make a deal with the devil. Most people imagine space travel as a series of short bursts, a rocket firing, a sudden jolt of G-force, and then a long, silent drift through the dark. But to cross the immense and inconceivable distances between galaxies, drifting is a death sentence. To reach the beyond within a single human lifetime, we cannot drift. We must accelerate, and we must never stop. We're going to imagine we have constructed a ship capable of a constant 1g acceleration. This is not a number chosen for its mathematical elegance, it is chosen for you. 1g is the acceleration of 9.8 meters per second, every second. It is the exact force that pins you to your bed at night and keeps your feet on the floor. On this ship, you would feel perfectly normal. You could pour a glass of water, and the liquid would fall straight down. You could walk through the corridors with the same gait you use on a Sunday morning at home. But this comfort is a mask for a monstrous physical reality. By maintaining this constant push, your velocity increases by 10 meters per second for each and every second that ticks by. After just 10 seconds, you are moving at 100 meters per second. After 2.5 hours, you would have sailed past the moon. After a day and a half, you are at Mars. Then comes the first true milestone of the deep. After just 3 weeks, your ship would overtake Voyager 2. Consider the weight of that moment. Voyager 2 was launched in 1977. It has been hurtling into the dark for over half a century, carrying the message in a bottle of human civilization. It represents the absolute limit of our current reach. You would pass it in 21 days. At this point, your ship is travelling at 40 million miles per hour, roughly 6% of the speed of light. It is fast, but it is not yet weird. Einstein's theory of special relativity has not yet begun to warp your world. For the first year, life on board remains mundane. You eat, you sleep, you watch the stars. But with every passing day, your ship is travelling 2 million miles per hour faster than it did the day before. It is here that you notice the first crack in your connection to the human species. It is now impossible to have a live conversation with anyone on Earth. Even at 6% of the speed of light, the time it takes for a radio wave to travel back and forth is measured in months. You're no longer part of the web of human interaction. Instead, your loneliness is alleviated by regular letters from home, ghost stories updating you on political scandals, scientific breakthroughs, and sports results that happened months before the signal even reached your antenna. Then, 15 months into your journey, you hit the devil's bargain. Your crew realizes they have passed a threshold known as the Lorentz factor. Specifically, your Lorentz factor has hit 2. This is the point where the physics of the universe stop being a curiosity and start becoming a visceral horror. A Lorentz factor of 2 means that time has split. Because you are now travelling at 87% of the cosmic speed limit, the speed of light, the time dilation between you and Earth is exactly double. To you, on the ship, a clock on the wall ticks forward normally. You feel your heart beat. You watch a second hand move. But to an observer back on Earth, looking at you through a theoretical telescope, you would appear to be moving in slow motion. The reverse is even more unsettling. If you could look back at Earth, you would see the planet moving in fast forward. For every month you spend on the ship, 2 months pass for your family on the ground. Their lives are flickering away like old film reels, while yours remains frozen in the amber of your velocity. Your children are aging years while you age months. This is the steep price of reaching the edge. You are not just moving through space, you're actively discarding your place in human history. To understand why this is happening, we must confront the unintuitive nature of light. Einstein's theory, which has been rigorously tested and proven, states that all observers, no matter how fast they are moving, will always see the speed of light as the same constant. Imagine a horse chasing a moving train. On Earth, if the horse runs faster, the train appears to slow down relative to the horse. But in the deep universe, if that train is a beam of light, it does not matter how fast you run your ship. The light will always recede away from you at exactly the same speed, 299,792 kilometers per second. You can never catch it. Because the speed of light is a non-negotiable constant, space and time must shift to accommodate the rule. Time slows down for you, and the ship itself actually appears squashed in length to an outside observer. As your Lorentz factor climbs, the view out of your window begins to warp into a tunnel vision illusion. The universe you once knew is disappearing. Looking back, the sun has faded into darkness 10,000 times faster than you would expect from simple distance. It has become a dim, red ghost, its light so red-shifted by your velocity that it has moved into the infrared band, becoming invisible to the naked human eye. Ahead of you, the opposite is happening. The stars you're hurtling toward, like Alpha Centauri, are now 10,000 times brighter than they should be. But they aren't twinkling. Their radiation is arriving as high-energy ultraviolet light. The constellations are distorting, bending toward the center of your vision, as if the universe is being sucked through a straw. In a very real way, you are disconnecting from the rest of the universe. You're becoming what physicists call a historical relic. If you were to turn the ship around at this 15-month mark and return home, you would not return to the Earth you left. You would return to a world that has moved on by years in your absence. You're a passenger in a time tomb. This is the reality of the 1G journey. It is a one-way trip through the velocity of silence. The real world, the world of coffee cups, morning news, and growing children, is now a ghost story, being beamed to you across a gap that is widening every second. You're now 15 months into a journey that will eventually take you billions of light years away. But the most terrifying distance you have crossed isn't measured in miles. It is the gap between the time you're living in and the time the rest of your species is leaving behind. As we approach the cosmic speed limit, the very nature of space itself begins to change. For the first year of our journey, the vacuum of space felt like a hollow stage, a silent, empty backdrop through which our ship glided without resistance. But as our velocity continues to climb, we are discovering that the nothingness of the universe is a lie. At 99% of the speed of light, the vacuum is no longer empty. It has become a physical, violent medium. It has become a wall. Right now, if you were to look out the forward observation port, you would not see the stars as they appear from a backyard on Earth. The familiar constellations have vanished, replaced by a tunnel vision illusion. Because of relativistic aberration, the light from the stars ahead of you is being gathered and concentrated into a narrow, blinding circle, directly in front of the ship. It is as if the universe is being sucked into a straw. But there is a more unsettling transformation occurring. These stars are no longer white or yellow. Because of the relativistic Doppler shift, the light waves are being crushed together by our immense speed. The visible light is being blue shifted with such intensity that it has moved beyond the range of human vision into the high-energy ultraviolet and X-ray spectrum. To your naked eye, the stars ahead are fading into a ghostly violet haze, while the ship's sensors are screaming with warnings of lethal radiation. This is the first complication of our deal with the devil. The faster we go, the more the universe tries to blind us. However, the visual distortion is merely the preamble to the physical violence occurring outside the hull. We often describe the interstellar vacuum as empty, but empty is a relative term. On average, the space between stars contains roughly 1 hydrogen atom per cubic centimetre. In a room on Earth, that would be an absolute vacuum. But when you're travelling at near-light speeds, these lonely atoms are no longer gas. They have become nuclear sandpaper. This is not speculation. This is a visceral physical reality confirmed by the laws of special relativity. When your ship strikes a single, stationary hydrogen atom at 0.99 C, it does not simply bounce off the hull. To the atom, it is the ship that is stationary. and the atom is a high-energy particle hurtling toward it at 300,000 kilometers per second. Each collision is equivalent to a tiny nuclear detonation against the shielding. At this velocity, you're not just traveling through space, you're being relentlessly sandblasted by it. Every square centimeter of your forward hull is being subjected to a continuous microscopic bombardment. If you could hear through the vacuum, the sound would not be a roar, but a high-frequency metallic scream, the sound of individual atoms eroding your protection, grain by grain, into nothingness. To make this number real, imagine holding a piece of fine-grit sandpaper against a spinning lead pipe. At first, nothing seems to happen, but leave it there for a day, a week, a year. Eventually the metal thins, the structure fails. Our ship is the pipe, and the universe is the sandpaper. This creates what engineers call a ludicrous shielding requirement. We're no longer worried about space rocks or asteroids. At these speeds, those are not the primary threat. The threat is the momentum of the infinitesimal. Consider a single speck of space dust, a microscopic fragment of silicate no larger than a grain of smoke. In the shallows of our solar system, this is a nuisance, but at relativistic speeds the physics of momentum are rewritten. A single speck of space dust now has the momentum of a freight train. If such a particle were to breach the electromagnetic shielding and strike the physical hull, it would not leave a dent. It would trigger a kinetic explosion that would vaporize the surrounding metal instantly. You're flying through a cosmic minefield, where the mines are invisible and the explosions are constant. As we move deeper into this relativistic violence, a deeper complication emerges. The interstellar gas isn't just eroding the hull, it is turning the interior of the ship into a hazardous radiation environment. When those hydrogen atoms strike the shielding, they produce secondary radiation, Bremsstrahlung, or braking radiation. These are high-energy X-rays and gamma rays that can penetrate even the thickest lead linings. You're essentially living inside a giant particle accelerator. The ship's crew must live in a central tomb, a heavily shielded core at the very heart of the vessel, never venturing toward the outer hull, listening to the silent, invisible fire of the vacuum outside. This is the psychological price of the abyss. You're trapped in a small, sterile room, moving at a speed that has already severed you from human history, while just a few meters of metal away, the universe is trying to disassemble you at the atomic level. You're perfectly safe, provided the deal with the devil holds, provided the energy required to maintain the shielding does not falter, and provided the nuclear sandpaper does not find a thin spot in the armor. The data shows that this effect only intensifies as we go further. As our Lorentz factor increases, the density of the sandpaper appears to increase as well. The universe is compacting in front of us. Because of a length contraction, the distance between those hydrogen atoms is shrinking from our perspective. We are striking more atoms per second than we were a month ago. The universe is becoming thicker, more resistant, more hostile the harder we push against it. We are now approaching the limit of what a physical structure can endure. Looking back, the local fluff, the relatively dense cloud of gas that houses our sun, is now a distant memory. We are moving into the local void, a region where the density of gas drops significantly. For a moment, the sandblasting might quiet. The nuclear detonations might become less frequent. But in this relief, there is a new kind of terror. The local void is 150 million light-years of nothingness. By entering it, we are leaving the last neighborhood of galaxies behind. The light from the stars ahead is now so blue-shifted it is invisible, and the light from the sun behind is so red-shifted it has vanished. You're now in a place where the sandpaper has stopped, but only because there is nothing left to strike. You're moving at the cosmic speed limit through an absolute deafening silence. You're a monument to a species that likely no longer exists, travelling in a vessel that is being slowly erased by the very space it occupies. We have survived the relativistic violence of the interstellar medium, and the nuclear sandpaper that threatened to erode our hull has finally gone quiet. But as the high-frequency scream of colliding atoms fades into a haunting stillness, we are crossing a threshold into something far more unsettling than physical debris. We are passing through the local sheet, and ahead of us lies the local void, a 150 million light-year grave of absolute nothingness. To understand where we are, we must look at the map of our cosmic neighbourhood. The Milky Way, along with several hundred other galaxies, is part of a flattened suburban structure known as the local sheet. It is roughly 46 million light-years in diameter, yet only 5 million light-years thick. It is the last shore of the material universe we know. As we cross its outer boundary, the density of matter doesn't just drop, it vanishes. We are entering a region of space so empty that it defies the very definition of a vacuum. This is the local void. Right now, if you were to look up at the night sky from your backyard on Earth, this void would occupy roughly 40% of everything you see. It is a giant black abyss that dominates nearly half of our perspective, yet you've likely never noticed it. This is because the central plane of our own Milky Way, filled with its bright stars and thick nebulae, acts like a curtain, hiding the mouth of the abyss from our view. We're essentially living on the edge of a cosmic cliff, staring into a hole so vast that it could swallow thousands of galaxies like our own without a trace. Inside the void, the average density of matter is so low that there is effectively nothing for light to bounce off of. On Earth, we're used to a universe where light reveals structure. It reflects off dust, gas, and stars. But here, in the heart of the local void, a beam of light can travel for millions of years without ever striking a single particle. This is not speculation. This is what the redshift data and infrared studies have confirmed. If you were to step outside the ship here, the experience would not be one of sight, but of absolute sensory deprivation. There are no stars to guide you. There are no landmarks to anchor your mind. You would be standing in a deafening silence, a place where the darkness is so absolute it feels heavy against your skin. You're 70 million light-years from the centre of this nothingness, moving through a region of the cosmos that the universe has essentially forgotten. This leads us to a complication. The local void is not just empty, it is growing. Because of cosmological expansion, the volume of this abyss is slowly increasing every second. As dark energy pushes the boundaries of the universe outward, the walls of the void, the superclusters of galaxies that surround it, are being pulled away. The void is like a bubble in a loaf of baking bread, expanding and thinning, while the dough of matter is pushed into increasingly dense filaments. We are currently inside a region that is actively trying to push us out. But even in this 150 million light-year grave, there is a lone survivor. Floating almost exactly in the middle of this abyss is a dwarf spiral galaxy known as NGC 6503. It was discovered in 1854, sitting just north of the constellation Hercules, but it wasn't until we developed modern observation techniques that we realised its terrifying isolation. NGC 6503 is a lonely galaxy, a tiny island of 30,000 light-years of stars trapped in an ocean of nothingness. When we look at NGC 6503 through our ship's sensors, its beauty is heartbreaking. It is permeated with bright red clots of heated hydrogen and shining blue nebulae, vibrant stellar nurseries where new stars are still trying to be born. But it is a galaxy with no neighbours. It has no companion galaxies to interact with, no tidal forces to trigger massive starbursts, and no cosmic web to supply it with fresh gas. It is a monument to isolation, a single spark of life in a darkness that stretches for 150 million light-years in every direction. The data shows something even more fascinating. Due to the gravitational pull of the Virgo supercluster, NGC 6503 is actually falling. It is approaching the local sheet at a speed of 43 kilometers per second. In a few billion years, this lonely galaxy will finally reach the wall of the void, where it will be saturated with interstellar hydrogen and shine with renewed vigour. But for now, it remains a ghost. It is a reminder that in the deep universe, You can be surrounded by 100 billion stars and still be utterly, profoundly alone. As we move deeper into the void, we must confront the psychological price of this scale. In the time it has taken to describe this galaxy, our ship has travelled thousands of miles further into a region where the sandpaper of the vacuum has completely stopped. There are no more hydrogen atoms striking the hull. There are no more tiny nuclear detonations. The silence outside is so perfect that you can hear the hum of the ship's life support as if it were a roar. You're now a passenger in a vessel that is crossing a grave of light. Most of the galaxies we see from Earth are formed in global filaments, bound together by invisible threads of gravity. But here, those threads have snapped. We are in a fatherless depth, a keeper of the secrets of the birth of the universe. Scientists believe these voids were created in the first few minutes of the universe's existence. During the chaotic mixing of matter and energy following the Big Bang, tiny density fluctuations, small areas where there was slightly less matter, were stretched by cosmic inflation. Over billions of years, gravity pulled matter away from these low-density regions and into the dense clusters we call home, leaving these giant bubbles of nothing behind. This is established science. The local void is not just an accident of nature, it is a fundamental part of the architecture of the cosmos. Without these voids to act as the empty rooms of the universe, the galaxies and stars that make up your very body could never have condensed into being. We owe our existence to the fact that this grave exists. But as we look out into the blackness, the reality of our journey begins to sink in. We are currently moving through a region where the average distance between grains of sand, the stars, is no longer 6 miles. In the local void, the distance is so vast that the analogy breaks down entirely. You could travel for a human lifetime at the speed of light and never see a single star. You would be a monument to times that once were, carrying the history of a planet called Earth into a place where time itself feels like an abstract concept. The darkness here is not just a lack of light, it is a lack of causality. In the heart of the void, you are disconnected from the rhythm of the universe. There are no supernovae to witness, no black holes to avoid, and no signals to receive. You're simply a point of consciousness moving through 150 million light-years of indifferent silence. We are now approaching the far wall of the local void. Ahead of us, the zone of avoidance is beginning to thin, and the sensors are picking up a massive gravitational influence. We are being reeled in. We are moving toward the heart of Laniakea, toward a mystery that has puzzled astronomers for decades. We have crossed the grave. Now we must face the great attractor. We have crossed the threshold of the local void, emerging from 150 million light-years of sensory deprivation. But as the darkness thins, we are not finding a peaceful harbour. Instead, we are discovering that we are caught in a current, a massive, silent, and irresistible flow of matter that spans the breadth of the sky. We have entered Laniakea. In Hawaiian, the name means immense heaven, and it is a fitting title for the architecture we now inhabit. Laniakea is a supercluster of galaxies, a sprawling web of light and gravity that stretches for more than 500 million light-years across space. To humanize that number, if the Milky Way, a galaxy of 400 billion stars, were the size of a single grain of sand, the Laniakea supercluster would be a desert stretching for over 30 miles in every direction, and every grain of sand in that desert is moving. Right now, as you sit in your chair, you're moving at 1.4 million miles per hour. You feel absolutely nothing. Your coffee does not ripple in its cup. The room around you is silent and still. But the ground beneath you, the planet you inhabit, and the entire galaxy you call home are all hurtling toward a specific point in the southern sky. We're not moving by choice, and we're not moving in a straight line. We're being reeled in. This is the blind pull. For decades, this movement was a profound embarrassment to modern astronomy. We could measure the speed, 630 kilometers per second, but we could not see what was causing it. We knew we were being pulled by a gravitational titan, a supercluster of unprecedented mass. But every time we pointed our optical telescopes toward the source, we saw nothing but a wall of black soot and shimmering stars. This is because the destination lies within the zone of avoidance. Imagine you're trying to look out a window to see what is pulling your house down a hill, but the window is covered in thick, greasy smoke. That smoke is the central plane of our own Milky Way. The very galaxy that protects us also acts as a blindfold, its thick disks of gas and dust absorbing and scattering visible light from the deep universe. We have spent centuries flying into the deep universe blind, reeled in by an invisible predator that we could only sense through the trembling of the galaxies around us. This is not speculation. This is what the data from X-ray and infrared surveys finally confirmed. By using wavelengths of light that can pierce through the dust of our own galaxy, astronomers finally caught a glimpse of the Titan. Located 250 million light-years away, at the heart of the Hydra Centaurus supercluster, lies the Great Attractor. Its heart is the Norma cluster. This is the gravitational basin of Laniakea, the bottom of the cosmic hill we are currently sliding down. Within this region, 100,000 galaxies, each filled with billions of stars and trillions of planets, are flowing like water in a river toward a single drain. To understand this flow, imagine a topographical map of a vast watershed. If you drop a marble anywhere on a specific slope, it will eventually roll toward the same valley. Laniakea is that watershed. The galaxies of the Milky Way, Andromeda, and the Virgo cluster are all marbles on the same slope, destined to converge at the Norma cluster. But here, a deeper complication emerges. Norma is not enough. When astronomers calculated the mass of the Norma cluster and the surrounding galaxies, the numbers did not add up. The Great Attractor is massive, certainly, but it lacks the sheer, ludicrous gravitational potential required to pull 100,000 galaxies at 1.4 million miles per hour. There is something else, something larger, something deeper. Behind the Great Attractor, 650 million light-years away, lies the Shapley supercluster. If the Great Attractor is the drain in your sink, the Shapley supercluster is the main sewer line. It is an exceptionally packed, massive concentration of thousands of gravitationally bound galaxies. It is so dense that it is essentially warping the movement of everything within a billion light-years. We are being pulled by a hierarchy of titans, a relay race of gravity where one massive object hands us off to the next, dragging us deeper into the cosmic web. This is the predatory nature of our reality. Most documentaries describe gravity as a gentle dance. But out here, in the heart of Laniakea, gravity feels like an ambush. You're trapped on a one-way conveyor belt, moving toward a concentration of mass so great that it would eventually spaghettify and consume everything we have ever known. However, there is a final cosmic joke to this journey. We will likely never arrive. Because of the expansion of the universe, the space between us and the Great Attractor is growing, even as we hurtle toward it. Dark energy is acting like an anti-gravity force, pushing the Norma cluster away from us faster than we can fall toward it. We are like a person running toward the back of a train that is moving away from them. We are gaining ground, but the destination is receding into the distance. Eventually, the expansion will win. The Laniakea supercluster will not condense into a single, massive clump of matter. Instead, it will disintegrate. The invisible threads of gravity that bind us to the Norma cluster will eventually snap, and we will be left drifting in an even larger, even darker void. But for now, the pull remains. We are still in the shallows of the great cosmic flow, feeling the tug of the titans behind the curtain. As we look ahead, the Great Attractor is no longer the end of the road. It is merely a waypoint. Beyond the titans of Laniakea, the universe is no longer made of neighborhoods and watersheds. It is made of fire and fury. We are moving toward the region of the universe where the first heavy structures formed, a wall of radiation and light that marks the boundary between the known and the unknowable. We are approaching the quasar wall. We have crossed the 2 billion light-year threshold. You're now so far from the suburbs of the Milky Way that even the memory of your home galaxy has begun to blur into the background radiation of the deep cosmos. Looking back, the Great Attractor and the sprawling webs of Laniakea have faded into faint thread-like filaments of light. Ahead of you, the architecture of the universe is changing. We are entering the region of fire and fury, where the first heavy structures of the cosmos began to condense out of the primordial dark. Here, at the edge of the deep universe, we find the quasars, the deadliest things in the universe. For a long time, these objects were a profound embarrassment to our understanding of space. When they were first detected in the 1960s, they appeared as tiny, pinprick sources of radio energy and ultraviolet light. Astronomers dubbed them quasi-stellar radio sources, or quasars, because they looked like ordinary stars. But there was a complication. Their redshift values were impossible. The light from these stars was so reddened by the expansion of the universe that it placed them billions of light-years away. To be visible at such a distance, a single quasar would have to be emitting more energy than hundreds of entire galaxies combined. This is not speculation. This is what the spectroscopic data confirmed. To understand what you're looking at, we have to look past the light. At the heart of every quasar lies a supermassive black hole, a gravitational titan with the mass of 1 billion suns. To make that number real, imagine our Sun, a star so large you could fit 1 million Earths inside it, is represented by a single grain of sand. If you were to pile up enough sand to represent the mass of a quasar's central black hole, you would have a mountain of sand several miles high. This is the heart of darkness that powers the most luminous beacons in the history of time, but a black hole is by definition invisible. The light you see does not come from the hole itself, but from its accretion disk, a swirling cauldron of superhot gas and debris that surrounds the event horizon. Imagine a sink drain in a house where the water is moving so fast that friction begins to turn the liquid into a blinding white-hot plasma. In a quasar, the water is made of entire stars and vast clouds of interstellar gas. As this material is reeled in by the black hole, it doesn't just fall. It enters a high-speed orbital race, circling the drain at near-light speed. The subatomic particles in the disk are moving so fast that they smash into one another with extraordinary velocity. This friction generates thermal energy on a scale that defies human comprehension. The material is superheated to millions of kelvins, hotter than the core of our Sun, causing it to radiate electromagnetic energy across the entire spectrum. This process is 50 times more efficient at creating light than the nuclear fusion reaction that powers the stars. A single quasar can shine hundreds of thousands of times brighter than the entire Milky Way. It is an engine of such ludicrous power that it can impersonate a star in our own sky from 10 billion light-years away. As you guide the ship closer, you witness the spaghettification of a star. Most documentaries treat black holes as insatiable vacuum cleaners that suck in everything indiscriminately. But the data reveals a more nuanced and more terrifying reality. For a quasar to shine, the black hole must be a particular size. If it is too massive, like the monster at the heart of Galaxy M87, it will simply gulp material down whole. But a quasar black hole is at the perfect scale to be a predatory chewer. As a star drifts too close, the tidal gradient, the difference in gravity between the side of the star facing the hole and the side facing away, becomes so extreme that the star is literally ripped apart into a long, fiery ribbon of gas. This material is then separated into subatomic particles and fed into the accretion disk, sustaining the beacon's lethal glow. This is why we call them the interstellar beacons of the early universe. Because quasars require such an immense fuel supply of gas and stars, they were far more common in the younger universe, roughly 10 billion years ago. This era, known as cosmic high noon, was a period of frantic star formation and galactic collisions. In that crowded, violent environment, black holes were constantly being fed, lighting up the darkness like LED lights around the branches of a Christmas tree. Today, most quasars have gone quiet. The black holes at the centre of galaxies, including our own, have already chewed through most of the available gas in their immediate vicinity. They are sleeping giants. But here, 2 billion light-years out, you are looking back into a time when the universe was still a cauldron of chaos. As we push further, we encounter the quasar wall. In the time it has taken you to process the energy of a single quasar, your sensors have detected something even larger. We are seeing large quasar groups, LQGs, vast, multi-billion light-year assortments of these beacons scattered across space. The largest of these, known as the huge LQG, is an assortment of 73 quasar galaxies spread across an expanse of 4 billion light-years. To put that in perspective, if the entire Milky Way were the size of a single coffee cup on your table, the huge LQG would be a structure stretching for over 12 miles. This scale is so immense that it challenges the cosmological principle, the fundamental rule of science that states the universe should look the same in all directions on a large enough scale. Finding a wall this big is like finding enormous tracks pressed into sand, and realizing you have no idea what could have made them. This is established science, and it is profoundly unsettling. You're now witnessing the transition from the structured, neighborhood feel of the local universe to a regime of absolute randomness and fury. These quasars mark the boundaries of the observable web, serving as the last lighthouses before we hit the regions of space that are expanding away from us faster than the speed of light. The psychological price of this view is a feeling of existential weight. You're looking at the most powerful objects in existence, yet you are seeing them as they were billions of years ago. By the time their light reaches your eyes, the stars they are currently chewing have been gone for eons. The galaxies they illuminate have long since merged or faded into darkness. You're travelling through a galactic graveyard lit by the ghosts of dead lighthouses. If you were to turn off the ship's shielding for even a microsecond here, the radiation from these beacons would not just kill you, it would strip the atoms of your body apart. You are perfectly safe inside your time tomb, but the universe outside is a hazardous radiation environment that views your presence with absolute freezing indifference. Ahead of us, the light is beginning to change again. The quasars are becoming more frequent, but they are also becoming fainter, disappearing behind a wall of cosmic expansion that we can never hope to overtake. We are approaching the redshift horizon, the point of no return where the ground beneath us is being pushed away faster than the speed of light. Right now, the space between you and every distant object in the cosmos is stretching. You cannot feel the expansion. You do not feel your limbs being pulled or the chair beneath you widening. On the scale of your house, your city, or even your solar system, gravity is a far more powerful sculptor, keeping the dough of our local reality tightly knit. But as we cross the 12 billion light-year threshold in our ship, we're entering a regime where the anti-gravity of the universe, a force we call dark energy, has finally won the tug of war. We're now in the region of the redshift horizon, witnessing what scientists call the disappearing act of space. To understand the complication we've just hit, we must look at the galaxies ahead of us. For the last several billion light years, we have been chasing them, accelerating at a constant 1g, pushing toward the edge. But as we cross this invisible line, the data from our ship's sensors begins to report something impossible and unsettling. The galaxies we are pursuing are no longer just moving away from us. They are being pushed away by the inflation of the vacuum itself at a rate that exceeds the speed of light. This is confirmed science. It does not break Einstein's rule that nothing can travel through space faster than light. Instead, it is the stage itself that is growing. Imagine you're a child running across the surface of a giant balloon, while someone else is blowing into it with ludicrous force. No matter how fast your little legs move, if the rubber between you and your destination is stretching faster than you can run, you will never arrive. The distance between points is being created everywhere, at every moment, widening the gaps between objects and throttling the light trying to cross the abyss. As we watch these distant galaxies, we witness a phenomenon that is truly visceral and haunting. Because the space between us is expanding so rapidly, the photons of light being emitted by those galaxies are being stretched out like an elastic band. By the time they reach our sensors, they have been shifted so far into the red end of the spectrum that they are almost entirely invisible. This is redshift, denoted by the letter Z, and it is the most reliable scale we have for measuring the deep universe. But there is a more terrifying visual effect. As a galaxy approaches this horizon, it appears to freeze in time. Because the light cones are being starved of photons by the expansion, the images we receive are arriving more and more slowly. To your eyes, the stars in that distant galaxy appear to stop moving. The supernova stop exploding. The entire spiral structure becomes a static red shadow, a ghost of a world that is effectively being erased from our causal reality. This is not a visual glitch. This is the boundary of the observable universe. We have officially hit the particle horizon. This is a spherical barrier that surrounds our position in space, beyond which no signal, no radio wave, no flash of light, no gravitational ripple can ever reach us. To make this number real, we have to confront a paradox that often confuses people on Earth. The universe is 13.8 billion years old. You might naively think that the furthest we could see is 13.8 billion light years. But because the universe has been expanding while that light was in transit, the particle horizon actually lies at a distance of 46.5 billion light years. We are currently standing at the 12 billion light year mark, but for us, the return ticket has already been voided. Calculations by multiple independent teams have confirmed that there is a round-trip horizon, a cosmic point of no return. That limit is approximately 8.3 billion light years. Because we have crossed that distance, even if we were to turn the ship around right now and point it back toward the Earth, we would never arrive. We can never return home. The expansion of the space behind us is now growing faster than our ship can travel through it, even at near-light speeds. The Earth, the Sun, and every person you ever knew are now effectively on the other side of a time tomb. You're not just far from home, you're causally disconnected from it. If the Earth were to explode tomorrow, the signal would never reach your ship. To the rest of the universe, you have already ceased to exist. You are now isolated and trapped in the void. The psychological weight of this realization is what many of the transcripts from your niche completely ignore. Most treat the horizon as a mathematical curiosity, but for the crew of the Hope, it is an absolute existential isolation. Your ship is now a monument to times that once were. Inside your sterile 1G environment, you are drinking coffee and reading ghost letters from an Earth that is, from your perspective, billions of light years behind a wall you can never cross again. You're essentially a passenger in a vessel that has exited the suburbs of the material universe and entered a fatherless depth. The data shows that this isolation will only intensify. As dark energy continues to accelerate the expansion, the bubble of our observable universe is shrinking. Right now, we can still see the faint red-shifted remnants of the galaxies we left behind. But in the distant future, those galaxies will move beyond the event horizon, the limit for any emitted signals beyond which none will ever reach the recipient. One by one, the lights of the universe will go out, not because the stars have died, but because their light can no longer bridge the widening gap. Eventually, you will be left in a universe where the Hubble horizon has collapsed. In this state, you could look out your window for trillions of years and see absolutely nothing. No stars, no galaxies, no cosmic microwave background. Just your ship and the deafening silence of a space that has expanded so much that there are no longer any other particles within your entire observable range. This is the disappearing act of the redshift horizon. We are currently moving at 0.99 C through a region where the nuclear sandpaper of the vacuum has been replaced by a perfect, terrifying emptiness. We are striking nothing because there is nothing left to strike. The universe is actively trying to erase the record of our journey, stretching the tracks we left in the sand until they are indistinguishable from the desert itself. This is confirmed science. The cosmic joke of our reality is that the more we learn about the scale of the universe, the more we realize how trapped we are within it. We have traded our history, our families, and our planet for a view of the infinite, only to find that the infinite is a place of absolute and indifferent isolation. But even here, at the edge of the observable web, there is one final landmark to see before the darkness becomes total. Beyond the 12 billion light-year mark, we are no longer looking at galaxies like our own. We are looking at ragged, small and primitive structures, the embryonic galaxies of the early universe. We are entering a cosmic dark age, moving back through time to witness the very first sparks of light that ever existed. We are approaching the cosmic dawn. Now we must face the time barrier. We are heading toward the limits of human vision, the moment the first stars began to shine through the darkness of the Big Bang. We have arrived at the limit of human vision. Behind us lies the entire architecture of the modern universe, the galaxies, the superclusters, and the violent quasar beacons. But as we cross the threshold of 13.5 billion light-years, the view begins to change into something ragged, small and primitive. We're no longer looking at developed spiral structures like our own Milky Way. Instead, we're seeing the embryonic galaxies of the early universe, tiny torrid pockets of gas and ancient stars that formed when the cosmos was in its absolute infancy. This is established science. To look into the deep universe is to look back through time. A telescope like the James Webb is, for all intents and purposes, a TARDIS. Its infrared eyes allow us to know the cosmos at every single stage of its life. But as we push even further back, we hit a complication. The lights go out. Before the first galaxies took shape, we enter a period known as the Cosmic Dark Age. This was the time that came after the Big Bang, but before the first stars were born. It is a chilling thought. There was a period in history where space was completely dark, colourless, and transparent. If you were standing in the middle of the universe then, you would see absolutely nothing. No stars, no nebulae, just a vast dark ocean of neutral hydrogen and helium gas. To make this number real, if the history of the universe were compressed into a single 24-hour day, the Dark Age would occupy the first few hours after midnight, a time of deafening silence before the first sparks of light ever existed. But then, roughly 13.8 billion years ago, the universe experienced its cosmic dawn. Out of the cold, neutral gas, the first generation of stars began to shine. These are known as population 3 stars. They were different from any star you've ever seen in the night sky. While the sun is polluted with heavy metals like carbon and oxygen from previous generations of dead stars, population 3 stars were primordial. They emerged directly from the pristine gas left behind by the Big Bang, pure hydrogen and helium. They were monsters. These first stars were likely hundreds of times more massive than our Sun, burning with a luminous and violent intensity that has never been matched since. Their birth triggered a massive phase transition in the history of the cosmos, the epoch of rionization. This is not speculation. This is what the data from our most advanced observatories confirmed. As these first stars ignited, they blasted the surrounding universe with intense ultraviolet radiation. This radiation was so powerful that it began to re-ionize the neutral gas, stripping electrons from their atoms and turning the dense fog of the early universe back into a transparent charged plasma. Astronomers are currently investigating whether this process was shared democratically among all galaxies or driven by a few large galactic oligarchs that acted as massive ionization powerhouses. But as we guide our ship even further back, past the first stars and into the heart of the Big Bang's immediate aftermath, we hit the final, absolute time barrier. Beyond the cosmic dawn, our optical telescopes are useless. We cannot see anything with our eyes, or even with infrared sensors, because the universe before this point was opaque. For the first 379,000 years of its life, the universe was so hot and so dense that it was essentially a luminous high-energy plasma. Photons, the particles of light, could not travel more than a few inches before being absorbed or scattered by free electrons. The universe was a dense fog of light that could not move. Then, at exactly 379,000 years after the Big Bang, the temperature dropped enough for electrons and protons to combine into the first stable atoms. This moment is known as recombination. Suddenly the fog cleared. The universe became transparent, and for the first time in history, light was able to spread freely over long distances. That first light is still travelling through the universe today. We call it the cosmic microwave background, CMB, the afterglow of the Big Bang. This is a visceral physical reality. Even though you cannot see the CMB with your naked eye, its intensity is all around you. Because the universe has expanded so much since that light was first emitted, the waves have been stretched out, red-shifted, from visible light into the radio and microwave spectrum. If you've ever owned an old, untuned television and seen the snow or static on the screen, you have seen the edge of the universe. A small portion of that radio static is actually the CMB, the pervasive echo of the Big Bang being picked up by your antenna. You are witnessing the birth of the universe in your own living room. The CMB is the university's very own baby picture. It is a snapshot of the moment the Big Bang ended, revealing seeds of structure formation, tiny temperature fluctuations where the blue areas are below average and the orange areas are above. These spots were the blueprints for every galaxy, star and human being that would ever exist. But this baby picture is also our absolute limit. The radius of our observable universe is measured by the distance travelled by these oldest photons. While they have been streaming for 13.8 billion years, the space they have travelled through has expanded so much that their proper distance is now 46.5 billion light-years away. This is why the observable universe is often cited as being 93 billion light-years in diameter, despite only being 13.8 billion years old. We have reached the edge of the Hubble volume. Beyond this curtain lies the unobservable universe, a place that remains shrouded in mystery, because its light has simply not had enough time to reach us yet. This is the ultimate deal with the devil. We have travelled back to the very instant of creation, witnessing the most violent and creative moment in history. We have seen the sparks of the first stars flying out from the Big Bang like debris, but there is a final, unsettling complication. As the universe continues to age, more ancient light will arrive, and our observable horizon will technically grow. But because the expansion is accelerating, those distant galaxies will eventually fall off the grid. They will manifest only as dark, elongated red shadows frozen in time, becoming forever unreachable and unobservable. We are standing on the shore of a vast, incomprehensible ocean of emptiness. Behind us is the history of everything. In front of us is the Dark Era, a period where time itself may cease to matter. We have reached the limit of what can be known. We have touched the time barrier. The hum of the ship's life support is currently the only sound in the entire cosmos. Inside this small, pressurized tube of metal and ceramic, the air is a constant 22 degrees Celsius, and your coffee is still warm in its cup. But outside the hull, the universe has performed its final and most terrifying disappearing act. For the last several 100 trillion years, while you were protected by the artificial gravity of your 1G acceleration, the stage upon which the stars once danced has been stretched into absolute nothingness. This is confirmed science. Because of the relentless push of dark energy, the expansion of the universe did not just continue, it accelerated to a rate that defies any human sense of scale. To understand the isolation you are now experiencing, we have to look at the numbers. At this point in your journey, the universe has expanded by a factor of 10 to the 10 to the 55. That is a number so ludicrous that if you were to try and write it out 1 digit per atom, you would run out of atoms in the observable universe before you were even a fraction of a percent of the way finished. The result of this expansion is a reality of complete and absolute isolation. The galaxies you once chased, the interstellar beacons that served as your lighthouses, and even the faint afterglow of the Big Bang have all been pushed beyond your event horizon. They are moving away from you faster than the speed of light. In this state, you could look out your observation port for 1 trillion years and you would see absolutely nothing. Not a single photon of light from the outside world will ever reach your eyes again. You're no longer a traveller in a universe. You are the inhabitant of your own, private, terminal space bubble. As the seconds tick by on your ship's clock, a deeper and more visceral complication is beginning to occur. You're witnessing the black hole era and the transition into the dark era. But even the black holes, those gravitational titans that once ripped stars into fiery ribbons of gas, are not eternal. Through the slow, agonizing leak of Hawking radiation, every black hole in the cosmos has eventually evaporated into a faint mist of subatomic particles. But here is the heart of darkness of our investigation. The matter itself is starting to fail. This is not speculation. Modern theories, such as the theory of grand unification, suggest that the proton, the very building block of every atom in your body, your ship, and your coffee, is not stable. After a period of roughly 10 to the 34 years, protons begin to decay. They disintegrate into ghostly neutrinos and flashes of light. Right now, the very walls of your ship are beginning to dissolve at the subatomic level. The nuclear sandpaper that once threatened your hull has been replaced by a silent catastrophe happening inside the atoms themselves. You are living in a tomb that is hurtling into nothingness, but the tomb is made of sand that is blowing away in a cosmic wind. Every person you ever knew, the sun that nurtured your species, and the earth that served as your blue pearl, are now billions of light years behind a horizon you can never cross again. They are not just far away, they are causally disconnected from your existence. If you were to scream into the void, your voice would have no medium to travel through, and even if it did, there is no one left to hear it. You have become a monument to times that once were. You're the last repository of 1 billion years of human history. Inside your ship's database is an ancient library of languages no one speaks, music no one hears, and scientific breakthroughs that no longer have a physical universe to act upon. You are a witness to a golden era that has long since passed into the night. The psychological price of this isolation is an existential weight that is almost impossible to carry. Most people think of the end of the universe as a sudden explosion or a grand finale, but the data shows it is something far more cruel and drawn out. It is a slow, cold suffocation where the lights of the cosmos go out one by one until only you remain. You might wonder if this is a cosmic joke, that we were teased with the jewels of exploration, only to be locked into an eternal grave. But there is a different way to view this final beat. As you sit in the silence of your dissolving ship, you realize that your entire journey was a testament to the ludicrous ambition of a small rocky species. From a remote little outpost in the solar shallows, you managed to unlock the secrets of the fire and fury at the edge of time. You traded your life and your history for the chance to see the cosmic dawn and the quasar wall. You have reached the limit of human understanding, and while the nothingness ahead is absolute, the fact that you are there to see it is the most interesting thing you will ever know. This is established. The universe is vast, silent, and entirely indifferent to your arrival. It does not care that you are the last monument to a world called Earth. It does not care that your species once dreamed of warp drives and wormholes. It simply continues its expansion, stretching the tracks of your journey until they are indistinguishable from the absolute void. In the final moments before the time barrier consumes the last of your ship's energy, you're struck by a single, domestic truth. The real world, the one of morning news and growing children, was a moment in the sun that you were lucky enough to inhabit. Like all things, the universe must eventually end, and your journey has brought you to the very last page of the book. There will be no forward momentum after this. There are no more instruments to build, and there are no more questions to answer. The investigation that began with a ripple in a coffee cup on Earth has ended in a perfect, terrifying emptiness. As the ship's lights flicker and the silence becomes total, you find yourself returning to the same feeling that every human who ever looked at the stars has felt. You're small, you're a microscopic speck in a cauldron of chaos, but you're a speck that looked back at the giant. You're a grain of sand that stood in a 30-mile desert and dared to measure the distance to the next grain. The universe is enormous, and that is the most interesting thing you will ever know.